Okay, Mr. Ibrahim. We are moving on to the second derivatives. First of all, we need to know that what is the second derivative. Guys, you see that when you differentiate something with respect to x, we write it as d by dx of that. Okay, suppose that is f of x over here. Now, this is its derivative. If you differentiate this again, so like when you differentiate this, this becomes f dash of x. Okay, if you differentiate this function again, this f dash of x, so as a function, this would be written as f double dash of x. That is its second derivative. Similarly, if you have, if you people are differentiating y, for example, there is d by dx of that y, okay? So that would be dy by dx, okay? If you want to differentiate this again, so that would be d by dx of d by dx of y, okay? So this becomes d square, that is d, we read it as d2y, and this is dx. Dx into dx is going to be dx square. Okay, this is dx square. Now there is, this square is not on just x. Dx is basically one thing. Okay, like you have, for example, there is f of x square. So we write it like this. The square is not on x. So this means this is f of x. Well, you will be studying this later. So this is, if you have dx and then again dx, so that is like you have sine x times sine x. So that is sine square x. That is, this square is not on the angle, okay? So similarly, when you're differentiating this again, so this is going to be d to y by dx square. Suppose you want to differentiate this once more. So that would be d by dx of d to y by dx square. So this would be written as d3y over dx cube. Okay. So now, how to find that derivative? Let me explain that to you. Um, Look at this first question here. You have y equal to 1 part a. You have y equal to x squared plus 8x minus 4. Now, when you differentiate this for the first time, that is its first derivative, that will be 2x plus 8. And if you want to find its second derivative means d2y by dx square. So we are differentiating the whole equation once again with respect to x. So the left hand side would become d2y by dx square, and the right hand side would simply be 2, because you have 2x plus 8. So the derivative of 2x plus 8 is going to be 2. Okay? Similarly, if you people look at this, um, maybe this 1e, okay? You have y equal to under root 4x minus 9. So first of all, you cannot find this second derivative directly. You will have to have the first derivative, only then you can get the second derivative. So its first derivative is 1 over 2, and this is 4x minus 9. I have explained this method to you a lot many times, okay? So this is, this dy by dx is 2 over under root 4x minus 9. Now we need to differentiate this again. So for that purpose, I will just write it in the form where I can really differentiate the right hand side. So I will be writing it in this form. Because you know this expression was in the denominator, I have to move that into the numerator. So now this, now I can differentiate this d2y by dx square, that is 2 into minus half into 4x minus 9, minus half minus 1 is minus 3 by 2. And then its derivative. Never forget to differentiate this thing which has the power, okay? So we have minus 4 over 4x minus 9 raised to power 3 by 2. That is the second derivative of this 1e. Okay. Now, similarly, if I take you to this two part f, okay, in this two part f, let me cover this. Okay, two part. I have already told you that what does this f double dash of x mean. So you have f of x. When you differentiate this f of x, this becomes f dash of x. When you differentiate this again, this f dash of x, then this would become f double dash of x. Okay, so now let's differentiate, let's find this double f double dash of x. So f part, you have f of x that is equal to 15 over the cube root of 2x plus 1. Before I differentiate, I need to write it in the form that we can really differentiate. So this has to be written in this form. Okay, so now we have f dash of x. So that will be 15 into minus 1 over 3. People, you must be well versed with all these techniques now, okay? Now this is minus 4 by 3. And then never forget to write its derivative, the derivative of this thing which had the power, okay? So 3 fives are, so this is minus 10 into 2x plus 1 raised to power minus 4 over 3. If that was what I needed, then I could have written this as minus 10 over all of this with the power 4 over 3. But you see, I still have to differentiate this again. So I will let it be in the same form. Now, we have this f dash of x, that is minus 10 into 2x plus 1 raised to power minus 4 over 3. We need to differentiate this again. So the left hand side would be written as f double dash of x. And now again, that power rule has to be used here. Minus 10 into this minus 4 over 3. And then into this 2x plus 1. And you see minus 4 over 3 minus 1 is minus 7 over 3. So you have the power minus 7 over 3. And please never forget to write the derivative of this thing inside these brackets. Okay, so this is going to be 10 fours are 40 times 2 is 80 by 3 into 2x plus 1 raised to power 7 by 2. That is its second derivative, the second derivative of this function. Okay, so bacho, it's your time, your turn to try these, try them out. Okay, so I'm going to clear them. You have the answers with you. You have to do all the parts of question number 1 and 2. You remember, this is the rule that whenever you learn a new technique, try all the basic parts. Once you are able to solve, handle these easier parts, you can easily solve the application parts, inshallah.